So hey guys, we're in the Sankofa Science lab and we have some things to do. Akerele, what are we gonna do today?
So I have this project that I've been starting on, and I need measurements for it, new measurements. So today we're just going to learn the percentages and how to get the right numbers.
Yeah, but okay, that's cool. I can help a little bit out with that. All right. However, what is your portion? What's your project? What are we actually doing?
Making videos for my Stikbot.
Stikbots, y'all. So with Stikbots, I'm learning with Akerele, my daughter. It's really amazing. It's so many skills and processes while making Stikbot videos. I didn't realize how amazing, how fun, and how accurate, and how what's the word I'm looking for? You can describe it more. What are some of the skills you have to use, like patience, with Stikbot videos?
Well, yeah, you do have to use a lot of patience because you have to take pictures, and like this, you have to move it slowly. If he was trying to walk, you would have to also have a lot of props and stuff.
Yeah.
So we invested in that.
Yeah, so it's super fun. So your end product is this really cool animated video, right?
Yeah.
With the storyline.
Yes.
So you're putting a lot of things together. You're putting a storyline together. There's your writing. You're making costumes. You're setting up your scene, making props, the whole shebang, the whole production. And Akerele is saying you have to be patient because you have to move the character motion by motion to create that scene. It's really cool. But Akerele, remember you said you wanted to make the Falling Waters?
Yeah.
Yeah. That was like last spring, y'all, but you know, COVID happened. I was full-time teaching and we were all transitioning into COVID distance learning. So now we're picking back up this project and we're gonna make it happen, right? So Akerele was telling me that this is your tallest figure?
That's my tallest figure.
Okay, so this is the tallest figure, and the blueprints that she found online was 14.7 centimeters at the tallest. And this guy is how tall?
Let's say around 14 centimeters.
14 centimeters. And the ceiling would have been, on the blueprints, the ceiling is 14.7.
Probably wouldn't even fit his head.
Right. It really wouldn't fit. So what we're having to do is, you measured what again? How tall you want the
ceiling to be? 17 inches.
So we have to put in a little bit of math work, put our brains together and do a little math. So yes. So Akerele's figure, the blueprint of the wall is 14.7. But she wants, so let me get out my dry erase board. Akerele, make sure, okay, I get your numbers right. In the blueprint, the wall is 14.7 centimeters tall, correct?
Yes.
Yes. And you want it to be 17. So 17 centimeters and 14.7. We want to find the difference. And the difference in centimeters is 2.3. I should have done the mirror effect, right? Yes. Okay, so we have a difference of 2.3 centimeters. Well, we can't just add 2.3 to all the sides, all the perimeter of all the walls in the structure. That would be not drawn to scale. So what we have to do mathematically is figure out what percent of increase is it from 14.7 to 17. What is 2.3? What percentage is 2.3 out of 14.7? So this is what we do. We set it up as a fraction. I explained to Akerele, let's think of it this way. When you are doing an assignment and you say, look, mama, look, daddy, I got 85. I got an 85. 85%. That means you got 85 out of 100 apart to a whole, right?
Yeah. Yeah.
A part to a whole. So when we apply that knowledge to our Stikbots, Akerele, which number is the part?
2.3?
Yeah, 2.3 is the part. And what's the total? What's the whole?
14.7.
Absolutely. So if we know that 2.3 is a part and 14.7 is a whole, what we're going to do is now find the percentage. That means we have to use a little bit of math, but just because we're doing a project, let's go ahead and use our calculator. And when we do 2.3 divided by 14.7, you get 0.156. Okay? That is so we took what type of number is this, Akerele? When you have a numerator or denominator, what is that called?
Fraction.
A fraction. We turned a fraction into a
decimal.
And then you turn that decimal into a percent simply by, do you remember? Moving
the zero.
We're not moving the zero, but the what?
The value?
We're changing the value, but we're moving the what? What did you say?
Placeholder?
Which is the decimal. So when you change, simply we work smarter, not harder. When you want to change a decimal into a percentage, you're going to simply move that decimal twice. How many zeros do we have in 100? 2. So we're going to simply move our decimal over 2 times. And our number changes from a decimal to a percentage, which is equal to 15.6%. Ta-da! Yes, guys. So we have to increase each side of the structure by 15.6%. It's going to take a little math, but we're two smart, young, beautiful ladies. We can do that. So scholars, once again, get in there, have fun. I think we should ask some people to join us, who wants to join us in creating Stikbots? I think we should have a little healthy competition. What do you think?
Sure.
We can invite the people to come join us, finish out the movies, have different scenes. So yes, y'all, we are going to get back to work.